So, in this video we're going to apply what we've learned about derivatives. Now remember, we've talked about what a derivative is, we've done it the algebraic way, we've done the quick approximation way, and we've done it in the calculator, and we've done the shortcut way, but now we're going to apply it. So for example, in 3.5, if we have the cost function, if I took the derivative, what would that be? So if I plug into the cost function, it would tell me the total cost, but if I took the derivative, that will tell me how the cost is changing. The derivative cost would be marginal cost, how the cost is changing. So, suppose the cost in dollars to manufacture portable CD players is given by cost equals 15,000 plus 20x minus 0.0001x squared, where the input is number of CD players and output is total cost. And I want to find out the marginal cost for the 50,000 and first CD player. Well, first of all, with every word problem, you need to clearly understand the input and output. Input, number of CD players, output, cost. So, to find the marginal cost, we take the derivative of cost. So, the derivative of 15,000 would be 0, the derivative of 20x would be 20, and the derivative of negative 0.0001x squared, 2 goes to the front, would be 0.0002x. So first, derivative using the shortcut method. And we want to find out what is the cost at the 50,000, or marginal cost at the 50,000 and first. Well, we're going to plug in 50,000. Let me explain why. The cost at 50,000, if I plug into the original, will tell me total cost of producing 50,000 CD players. When you plug into the derivative, that tells you how the cost is changing. How the cost is changing, and it's the cost of the next CD player. So, if I plug 50,000 into the derivative, you get 10. So the average rate of change for 50,000 CD players would be $10 per CD player. Remember, it's output over input, cost per CD player. So if I produced 50,000 CD players, the next one would be $10. $10. Now I can check all this in the calculator. Okay, so we go to our calculator, we go to y equals, clear what we have in there, and this would be a great way to check our work. So our original function is 15,000 plus 20x minus 0.0001x squared. That's my original. Now, I'm going to do the derivative in the calculator. Remember how we did that? Math, number 8, vars to the right for y vars, number 1 for function, y1, comma, x. That's going to be the derivative in the calculator. Then in y3, I'm going to type in my derivative, 20 minus 0.0002x. We're going to go to the table to plug in values, but remember, second window, make sure your table set is Ask Auto. If it's Auto, this won't work. Go to the table, second graph, delete any values you have in there. And when I type in 50,000, make sure you understand what everything means. 50,000 is how many CD players. Y1 would be total cost, $765,000. And then Y2 and Y3 should be the same. This is the derivative in the calculator. Derivative by hand, $10. It's a great way to check. Okay, that's one example. This other example, I'm going to let you kind of read through, and I'll go directly to the formula just to make this a little bit easier. But basically, here's our revenue function. Here's our profit function. The input is number of members. The output is revenue. For profit, the input is number of members. The output is profit. So remember, we said if we need to rewrite it to make life a little bit easier, we should to find the derivative. So here, since we have division, we took 46 divided by 0.06. That's where the 766.67q came from. And this would be a minus 1q squared. So 1 divided by 0.06 would be 16.67q squared. This is just a rewrite. Then when we take the derivative of 766.67q is 766.67 minus the derivative of 16.67q squared 2 goes to the front, subtract 1, would be minus 33.34Q. Now notice that profit and revenue are similar. The first part is revenue, so that's where this came from, the beginning portion. And then we just minus the cost, 100Q minus 5,000, simplify, put the negative 16.67Q squared in the front, plus, combine the Q's, plus 666.67Q minus 5,000. Get that in order. That's just a rewrite. There's your total profit. To find the derivative of negative 16.67Q squared is negative 33.34Q. The derivative of 666.67Q would be 666.67, and the derivative of minus 5,000 is just 0. So we're going to work with profit, and I want to find the profit at 15 members, profit at 20 members, profit at 25 members. Now, to find total profit, you plug into the original. To find marginal, you plug into the derivative. All of this can be done by hand by plugging into the functions. I'm going to show you how to do it in the calculator. So I go to my calculator, go to y equals. I'm going to clear the first one, clear the third one. I'm going to leave y2 derivative because that's the same. So make sure you use negative 16.67 x squared plus 666.67 x minus 5,000. There's your profit. And then in y3, negative 33.34 x plus 666.67 would be your y3. Now remember, y2 and y3 should be the same. It's a great way to check. And we're going to plug in different values. So for the first one, we're going to plug in 15. So I go to the table, second graph, plug in 15. Now, 15 is number of members. Y1 will be total profit. So if I had 15 members at my gym, you'd have 1,249.30 cents would be your profit. And then Y2 and Y3 are the same. That tells us we're doing it correctly. So what this is telling us that is that 15 members, if I got one more member to join, my profit would increase $166. Okay, so we should add members. Now let's see what happens at 20 members. So I add members, and I put in 20. My profit went up to $1,665.40, but what is this telling me? Negative 13 cents. It's telling me if I add one more member, my profit would decrease by 13 cents. So let's say you went to 25. Now your total profit actually decreased to 1,248, and it's telling me if I add one more member, it would go down $166.88. So let's think about this problem. We believe the more members, the more money. More members, more money. Well, if we think about it, if we have to have more members, we need another class. And if that other class isn't full, we're paying that instructor and the time and the lights and everything for just a few. You could actually be losing money. So we can take this problem and think, hey, when should I have stop adding members? Well, it's telling us that at 20 members, adding more would lose money. Let's see what happens at 19. So if I go back and plug in 19 members, it's saying at 19 members, if I add another member, I'd gain $33. Good idea. But when we got to 20, that's when it's telling me stop. If you add more, you'll be losing money, so we should have stopped at 20. Okay, here's another example where we're talking about annual profit. So output profit, input number of workers. So for this example, we're going to see what happens at 20 workers. So our original function is negative 200,000 plus 400,000 n minus 4,600 n squared minus 10 n cubed. Remember, n is number of workers. Derivative of negative 200,000 is 0. Derivative of 400,000 n is 400,000. Minus 4,600 n squared. 2 goes in front, subtract 1, gives you minus 9,200 n. And the derivative of minus 10 n to the third, 3 times 10 is 30, minus 1 is 2. So my derivative function is 400 minus 9,200 n minus 30 n squared. Remember, what is this? It's output over input, profit per worker. So again, I can do it all by hand. Plug 20 into my original, plug 20 in my derivative. We're going to check it in the calculator. So we're going to go to the calculator, go to y equals, remove y1, remove y3. And remember, in y1 we put the original, negative 200,000 plus 400,000 n, we'll put x, minus 4,600 x squared minus 10x raised to the 3. And then in y3 I put the derivative, which is 400,000 minus 9,200 x minus 30x squared. And when I plug in 20 workers, at 20 workers, my total profit would be 5.88 million. And if I got one more worker, I get an additional $204,000 profit. So should we add members? Absolutely. So at 20 members, my recommendation would be add more. When should I stop adding members? Well, let's go to 25. If I go to 25, still making more money. If I go to 30, still making more money. If I go to 40, getting a negative. So somewhere between 30 and 40. Let's do 35, still positive. 36, still good. 37, still good. So again, at 37, we have 7.8 million, and I'd make additional 18,530. At 38, I have 7.81 million, and I'd still make more money. At 39, it's telling me I would have 7.81 million, but if I added another member, I'd lose. So at 38, if we add, we gain, but after that, we'd lose. So I would stop at 39 members. And that's what that says down here. And then the last topic is average cost. I'm not going to spend too much time on this. Average cost is not derivative, it's not calculus. Average cost is simply taking cost divided by x. So you take your total cost divided by how many. The symbol for average cost is C with a bar over it. So if I wanted to find average cost, you take cost and divide by x. So the total cost of 50,000 would be 765,000. I would divide by 50,000 CD players, and my average cost would be $15.30. The formula would just be cost divided by x, and you can simplify by dividing everyone by x. But again, this is more of a basic concept, nothing with derivatives, but it's still important because average cost tells me the average of the costs. Marginal cost is different because it's cost of the next one. That concludes Chapter 3.